Hi, how are you? My name is Agustin Martinez. I am a researcher at the University of Buenos Aires. And well, today I will present a project I already presented in previous Smalltalks conferences. The project is now online. You can download it. It is a programming language for children, a visual programming language for children. I will make a little introduction to the project. I will make a demo. I will talk a little bit about the implementation, very little, and talk about challenges, future works, etc. of the project. So, well, this is a web page. You can download it. And, well, I will show things I already showed previously. This is an old version, the first version I presented in a small talk 2 years ago. Then I made a workshop with children at the University of Buenos Aires. I tested this prototype. I had some feedback and create a new version of it. Again, different children use them. They can create simulations and also program more abstract models. And well, this year I opened it for the public, and I also made some performance as an actor with my son at an event called Nerdearla. Maybe you know it, for children. And this was the launching of the project this year. So, well, I implement this using Smalltalk, using Quiz Smalltalk. Some statistics. I have 3 lines per method. I don't know if this is good or bad for you. I have my tests. I also, yesterday we were discussing with Christian about testing the visual elements, and well, I tell him that I simulate some visual elements so I can test also the visual model. And well, something about how I make it an application for to put it on the web. So it's just a little thing to show. So I used last year with Maxi here. I don't know, Maxi. We talk about how can we make some prototype to like an image which can be downloaded and used it by others. And he told me that he was using Faro for his project because Quiz didn't have that kind of support. So well, I was working in Quiz and I didn't want it to move, so I made my own way to create, to become a project, an application. So it's my own creation, and well, I ran evaluate an expression, and the image became this. This is the actual product that children will use. And well, they download it, they use it. I will make now a little demo. I wanted to mention this implemented aspect only to open some discussions later. Hey, how you do it? Well, I'm open for that, open for ideas about how to do it. I will make a little demo. I want to show you the how this environment works. Well, this is the main editor. The essence of this programming language is that you program through your own drawings. So I will make a drawing. I will make an ant. You start with your drawing, and then you throw your drawing. You can throw it several times, and you can create rules. Now, this is the definition of the program. Well, this is the program, and now I can control my ant with a keyword. So, well, I can create also like the ant leader. I want to create an ant, which is the leader. This special ant will be the leader. I want to use it, to move it, and I want other ants to follow him or to follow her. So the ant leader pulls other ants. So now an ant follows the leader, and also the ant pulls other ants. And in this way I can build some sort of train or swarm of ants. So let's say we want to create the enemy of these ants. You may know about this enemy. It's the famous ant eater. We can create the enemy. We can throw it. We can say that this enemy runs around this space. So here I have the ant eater and my train of ants, which are two phenomena that are parallel. And yeah, we didn't talk about parallelism. There are no syntax special for parallelism, but since things run in parallel or concurrent in real life, well, they can be expressed that way in this language. As you know, it has no starting point. So parallelism arrives naturally. Well, now we can create a rule. The ant eater, when it touches an ant or collisions with an ant, we want the ant to be eaten, so we can say that the ant is teleported to the black hole, to nowhere. So now he touched an ant, and well, the ant disappeared. But if this anteater touches the leader of the ants, will not eat it. No, we can make it run to the ant and will not eat it. So we can create another rule. We can say the anteater when collisions to the leader of the ant, etc. Or we can say that the ant leader is categorized by the notion of ants. So it's a particular ant. So here we created a category, a prototype-based category, and well, now if the anteater goes to the ant, it will eat it. So it is, as you see, like a game engine. You can create your own games. The game and the definition of the game can interact with it. So here we have a sheep that wants to go to the grass, and if the sheep moves, changes the rule, he can go out and, well, go to the grass. So as you can see, the simulation can change its own definition. Here it's a Pac-Man with very few rules. You can create your own Pac-Man, and well, it has a teleport. Can be, if the ghost touches the Pac-Man starts again. It's a very simple Pac-Man. As you can see, very simple rules, very few rules. Well, also you can work with abstract entities. You can implement, or the children can implement numbers, addition of numbers. Here I have some numbers drawn, 1, 2, 3, 4, 5. An arrow up, an arrow down. The arrow up represents the next. The next of 1 is 2. The next of 2 is 3. And the arrow down is previous. Previous of 2 is 1. And here I use the notion of categorization. 1, 2, 3, 4, 5 are categorized by this abstract notion of number. So let's say we want to make an addition, 1 plus 4, and we want to see the result. So we use the eyes to see. 1 plus 4 is 1 plus 4 because there is no substitution for that defined yet. So we will define a substitution, 1 plus the notion of number, any number. It is the next of that number. As you can see, I changed the definition and the evaluation changes. So, all right, 1 plus 4 is 5. Very good. Now, 2 plus 3. Let's see the definition. 2 plus 3 is 2 plus 3. So I need to, again, create a new definition of number, which will be a more a recursive definition. We have defined the base case here, 1 plus a number, and now a number plus a number will be the previous of the first one plus the next of the second one. And now we created. Well, no, there is no need for an applause. Well, you imagine how this execution works, no? In your head you can reconstruct it, but maybe we can see it. Why we have to use our head to reconstruct it? We can see the execution, which is called debugging in some sense. And here is the execution, 2 plus 3, it is transformed through this substitution rule, then the previous of 2, 1 plus the next of 4 of 3 is 4, and then the original addition with the base case. So as you can see, things like recursion can be introduced in a very simple way, very fast. There is no notion of variables. There are all other things that in some language appear that here we don't need to talk about. There is only two relations in this language, substitution and categorization. And with these two combinators, you can build your programs, abstract programs like numbers. So, well, that was a little introduction. As I told you 2 months ago, I opened this for everyone to use. You can download it. If you have children, you can use it with your children and give feedback. I encourage you to do it. Sorry? Represent.r. That's the URL. Because of this is like that programming is about representing creative models, and well, that's the name of the project because it's a conceptual name. I wanted to put it. Future works and challenges are, for instance, create content, in the videos, tutorial, etc., for people to understand this language, use it, and to develop this point of view of programming and creating representations to teach the core notions of programming, like recursion. Also, as I show numbers, booleans can be implemented. So logic, which is classical logic used in programming, can be presented for children in a constructive way. They can construct the booleans. I showed that 2 years ago in a previous small talk. Well, immediate feedback is a characteristic of this language, and parallelism concurrence, it's also a characteristic that, well, I think it's very important. And the other characteristic, which is part of the philosophy of Smalltalk, is what you see is what you get. You draw, you throw, and you create the environment of your characters, like this Pac-Man I show. You create it by throwing the drawings, etc., and you play with that you built. So if someone wants to participate, to create challenges, and we can put it here. This version works in Mac, Linux, and Windows. Doesn't work in Android, iOS. So if someone likes to program in the low level of the virtual machine and can participate and help making this run in a cell phone or a tablet, well, I'm happy to invite you to participate. And I want to present a challenge. Last year we said we have to make some games, we have to have some fun. How can we do it? Well, here's a challenge for the hackers in Smalltalk. The challenge is, I want to see the source code of my project. You download it from the represent.r webpage. There is an image file you will get. There are the represent.r files. You will find an image file, and from there, find the source code and show it to me. I buy a drink for the one that shows me the source code, and a drink for the one that can make it run in a Smalltalk image, run the test, etc. Another drink, 2 drinks of your choice. So, well, a challenge for the ones that like to program or believe themselves like hackers. Beer, you said?
What kind of beer? Because if
what kind of beer do you like?
What type of beer? Oh,
zero alcohol.
The best one.
If you want zero alcohol, will be zero alcohol or not.
Can we change it with my back?
You can change it for a coffee. If you don't drink alcohol, you can change it for a daiquiri. So, well, I hope someone gets emotional about the challenge and make it. Well, thank you very much. It's about the drink.
It's about the beer, yeah.
The beer, you call it beer.
No, beer
drink
and wine
means beer.
So, you tried this with kids. You show us that you did. But after that, have you tried again? Do you see that the kids gets a good sense of programming? What do you see after they use it?
Well, I tried more systematically or in a classroom context last year, a version of the language. I didn't make that again. I plan to do it again. I'm working with a colleague, also a student at the University of Buenos Aires. He's now focusing on that, on the research about didactic aspects and the use of this language on a curricula. So he will be leading these future classroom experiences. So I can tell you that I see some children in an informal way using this current version, but not in a school or not in a workshop open for the community as I did last year.
Okay. I have another question. So, you know that there are other tools for teaching programming to kids, like
Yes. Yes.
Scratch
Right.
and e-toys and so on.
Mm-hmm.
So, what do you think is the main difference? I mean, they're pretty clear differences, but why did you choose this way of programming instead of having blocks or like the other Scratch, e-toys do? Why did you select this idea?
Well, I believe if we consider that programming is the model to create representations, and you imagine something they want to create, well, start with the drawing is a good way to start. You can draw in other tools also, but the drawings are also the symbols you use to program. There are not other symbols than that. Well, there are some predefined drawings, predefined symbols, but they are also the symbols you use. And, well, the simplicity of this language. There are no primitive categories. There are no primitive types like in Scratch. You have booleans, numbers, and strings as primitive types, and it's very hard to create new categories. And here you don't need these primitive categories. You can build it by your own, and you can have all that you want. You can create the category of an ant if you want. So it is simple but very powerful in terms of categorization. And, well, there are notions like variables, etc., that they are no absent here. There are not need for them. You can represent the idea of a variable with a substitution. Some symbol is substituted by another sequence, and that's your variable. You don't need to introduce another concept. And you can go directly to core concepts of computing. I believe core concepts of computing, like recursion. No? Turing and Church, together, they said that was the essence of computing. We may think it's not the essence right now. Maybe the essence is about representing or modeling, but it's a very core idea of programming, and here you can go for it very, very fast, in a very easy way.
With the different symbols, you can create equivalences and basically have everything defined in its own terms. But do you have any state in the simulation?
A notion of a state.
Yes.
Well, your state could be a substitution. Now you can create, again, if you use it as a variable, or you can create a list. There are some list models here, and this list is changed. And here, I think we have a, I don't know if it's running. It's not right. This was made by Agustin, the other Agustin. Well, we have to check this. The ghost should go to the first element of this list. The list is changing, but the first element, no. But you can have some sort of state, and in a way, I know it is similar to functional programming in some ways. And in functional programming, you may consider that if when you add a new function, well, you change the state. And here you can dynamically create substitutions, so or change them. So in that way, you can represent some sort of state. Have to check that bug on the list project. Now, Carlos, have no more time. Okay, okay. No. One more question for Carlos.
Okay. I wanted to know if you have a mechanism to share the programs. I think in the classroom experience, it will be nice for kids to share their projects with other.
Yes, there is a way to share, very, very elementary. You put a name to the project, you push here, and well, a file is created. Not here. No. Where I'm working here, I'm working. Yeah. Ether, and you can send this file, and you can throw it to a new. You throw it to the environment, and it's loaded.
Great.
So this is the way to share. A very simple way to share. Not online, not a social network yet. Well, thank you very much.